Hello, everyone. Welcome to a presentation on the latest developments with the Participatory Planning Procedure Prototype, Pequod, where we're adding in pollutants. And I'm also talking about a new version of the software, which I've named Pequod Plus. Let us switch to slideshow, and I will give a very brief overview in a very quick slideshow that probably will last all of 5 minutes. And then I will demonstrate the software for everyone to see. For the goals and assumptions of the software at play here, the quick goal was pretty simply that Pequod for a long time, in fact, even to the development that we had done in anticipation for the book Democratic Economic Planning, that Robin and I, along with Michael Weisdorf, we meant to include in pollutants to see the environmental impacts of a participatory economy. But we never did. It turned out that that proved to be a more difficult problem than we had originally anticipated, so we postponed that. But in recent months, Robin and I have been working to do just that. Robin has been working out the mathematical formalisms for handling pollutants within the model of Pequod, and I've been working on coding that into a new project which I've named Pequod Plus. The going assumptions are that to handle pollutants requires us to kind of flip things around mentally regarding the model that's currently being used, where there are worker councils and consumer councils that exist within the model of Pequod. However, the supply of things up to now was handled entirely by the worker councils, and the demand for things was entirely handled by the consumer councils. For pollutants, that is reversed. The supply for pollutants now comes from the consumer councils, where the supply comes in the form of permissions to pollute granted by consumer councils. Conversely, the demand for pollutants now comes from the worker councils in the form of the right to pollute that is sought for by worker councils, or at least that's the going assumption. Moving on to the next slide. Can I click on it? There we go. Can I skip one? No. The updates to the algorithm are as follows. We include in a new price for a pollutant that is initialized along with the same arbitrary price vector to start out with that we do for all the existing goods within Pequod. But in addition, each worker council now has an arbitrary starting pollutant exponent value. You'll recall that we use the Cobb-Douglas function, and that function includes an exponent, a value that is raised to some power that is handled for various values given for various goods that the worker council is involved with. Here, we include in a related exponent for pollutants that represents an arbitrary starting point for how much a worker council wants to pollute. For each consumer council, we have two arbitrary chosen values, a positive utility value that represents income and a negative utility representing exposure, utility being the usefulness or desire for being able to consume. But there are two values that are related here for each consumer council. One that's positive, you get paid for basically for putting up with the trouble of being polluted. That's represented as income. But there's also a negative utility in that the pollutant might have, for example, a negative health impact on you that would represent an exposure and a negative consequence. Continuing on, Robin worked out the mathematical formalisms for this, and this is an excerpt, slightly revised, to account for some updates that we had made in the model for what they look like. The negative utility is represented in a value K, and the positive utility for income is represented with a value J, which are then, we then use a little bit of calculus. We take the derivative of each of the respective values and equate them to each other, and it is this equation that is then used to figure out the level of pollutant, the amount of pollution that a given consumer council will grant. That then is, I then took that mathematical formalism and rewrote it slightly to make it a little simpler, put it through a Mathematica function to solve, to actually figure out what that value for Z would be. The result is what you see in the second box, where Z is a value that's pretty complicated, but codable. And in fact, that's what the format in the third box represents. We actually take that value and transform it into a form that I can then write in, for example, the C programming language, but I can also adapt into the closure programming language, which is what we use for the programming here. There are some other additional updates that we have to make to the software. The production quantities, previously it just included 3 values: intermediate goods, nature, and labor, but now there's a 4th for handling pollutants, and so that required some updates to the data structure as well as the software themselves to handle a 4th value. And so I had to make various software updates therein. There is now we'll see in a moment, a 6th column. In addition to private goods, public goods, intermediate goods, nature, and labor, there is now a 6th column in the presentation of the web app to follow that includes pollutants. The year 2 augment, this is where we run a simulation for 1 year of an economy and then reset it to start it out for a second year once we've actually got a price vector that would work. We have to update the augment a little bit, but there's not much to change. Each worker council now includes an augment for each pollutant export, but there are no changes to be made for the consumer council with its augment. It just remains as it was before. And with that, we now move on to the live demonstration part of the show, where we go here, and you actually see I have a server working where I'm actually running the software on my computer here. This is actually a live read, evaluate, print loop that is running here. You can actually see I can run a little bit of code here, and this represents that I have a working bit of code, and in fact, an entire server. And here is the program itself. To review quickly, we have generated 2 experiments that we are going to run momentarily. Setup loads the values in. We then iterate to go through the same iteration that we did in the previous versions of Pequod, and we have an augmented reset once we have achieved the threshold. Here is the 6th column for pollutants in addition to the previous 5 versions. We check the prices, the rate of change for the respective prices, the price deltas, the current supply for a given good, the current demand for a given good, the difference between supply and demand, which is the surplus, the percentage of that, whether or not it is met, and that is color coded. We go from red, orange, yellow, green, and blue. The goal is to achieve either green or blue for all 6 of these boxes. We will now load in a single experiment with just 30 worker councils and 30 consumer councils. I should also mention that we now are, instead of having 10 public goods, which we had in the previous version, we just have a single public good, as well as at the moment just a single pollutant. The price deltas are set to a default value of 25%, and we are now in a position to be able to iterate through the economy. So let me actually change the formatting a little bit here, and we will now begin an iteration here. Change it a little bit more. We are now 1 iteration. You can see that there are some changes here that will go through. There is a lot of iterations here to go through, so I'm actually going to proceed fairly quickly, and you will see as things change. The screen will change as well. We're now in iteration 6. The goal again is to achieve, and this is a brand new economy, also to include in pollutants. We're proceeding through. We're now at iteration number 13. Pollutants are on their way through where they're below the 20% threshold. We're continuing on. Pollutants have actually responded rather robustly. We're now very close to the 5% threshold. Things are moving along across the board, but they're much faster in pollutants. In fact, they've already reached what we want for them, below a 5% threshold. 5% surplus to meet the threshold. As you can see, the public goods are now also approaching that, as are the intermediate goods. We're now at 30 iterations for the economy, for this rather small economy of just 30 councils, 30 worker councils and 30 consumer councils. And we're getting there. We're now up to iteration number 40. We want green or blue for everything. We now have blue on the public goods, but we're not quite there yet. We now have green for private goods. This is now for iteration number 47, 48, 49, 50, 51, 52. Oh, we're so close. 53. In fact, there's just 1 good there that's actually a difference. But let's see if we can get it on this one. 54, 55. There we go. So we now have achieved equilibrium in this economy for pollutants. Now notice this thing here. The pollutant, all these prices has started with a value of 700. Pollutants went up. And that kind of makes sense and is kind of what you're hoping for. You want pollutants to be bad, and you want them to be tracked, and you want them to be more and more expensive, and they are. They went from a value of 700 to now a current pollutant price of 11,823. But that's year one. We now want to reset with an augment for year two and see how it performs there. That's where the real challenge there is. We will run an augmented reset. The only change that you see on the front end is that for the iteration counter, which gets reset to 0. But we are now an update is now made throughout the entire system, and now we can actually begin a second year of the iteration and see if we complete this within a handful of instances. That's our goal here. I'm hoping for like fewer than 10. Let's see how it goes. Iteration number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, we're so close right there. There's just like the 1 there. 13, 14, one more, 15, 16, 17. Come on, there's like 18, 19. That took a little longer. I've never seen an iteration like this that take as many as 19 iterations, but it achieved equilibrium and kept things to a pollutant and did it in a reasonable fashion, although it is actually kind of high. What we can also do now is run the same procedure with a much larger experiment. I will actually refresh the page, and we'll run this for a second experiment, which now has 3,000 worker councils and 3,000 consumer councils. A word of note here, because there are more councils, there's a lot more processing under the hood to take place, and this will be slower. I'm actually going to run a single iteration now, and that completed, but it's actually going in the same direction we want. We'll continue on with here. Iteration number 2, 3. Nature and labor are actually already moving quickly to convergence. 4, 5, and we're continuing on. 6, continuing with 8, 9, 10. Again, this is a brand new economy that is 100 times as big as the one we had seen before. We've already got green on 2 of the values, so that's encouraging. 13, 14, 15, 16, 17, 18, kind of oscillating across the board here. Nature and labor were green. Now they are, well, nature is green, labor and intermediate value are yellow. Again, we want green or blue across the board. This is now iteration number 23, 24, 25, 26, 27, 28, 29. We're kind of close there. Well, now 30, 31, 32, 33. Prices of pollutants have actually increased more in this economy. So it's actually much more expensive to pollute here, which is what we want. 34, 35, 36, 37, I'm getting closer, 38, 39, 40, 41, 42, 43. Wow, we're achieving like blue. 44. Again, green or blue is the goal here. 45, 46, 47, 48, 49, getting closer. 50, 51. And you'll recall the last one, I think, was 55 iterations. Does anyone remember how many we got the last time? Almost there. We got 55, 56. Oh, come on. 57, 58, 59, 60, 61, 62, 63. Oh, come on. Get closer. All right, one more. Now it's 66 iterations. 67. 68. Okay, we've achieved, with a brand new economy, 100 times larger than the previous economy in 68 iterations, achieving equilibrium, green or blue, across the board. We'll now do an augmented reset, and now we'll see how many iterations this took. Previously had hit 19 with a goal of under 10. This is iteration number 1, 2, 3, close now, 4, 5, 6. Oh, we're getting close. We're so close. 7, 8, not quite. In fact, there's actually just two goods that are actually above the 5% threshold. Let's see if we get it on 9. Not quite. This has slipped out. There, going on to iteration number 10. Nope. Iteration 11. Yes. Okay, so we were with an economy 100 times the size of the previous economy. We were able to achieve equilibrium of 5% or better in 11 iterations, as opposed to the 19 iterations with a smaller economy. But it was achieved. And the pollutants, the goods, you can see the prices of the goods as they compare. Intermediate and private goods did go up. Nature and labor went down a little bit. Public goods went up, but pollutants really went up. Price currently of 55,266, which is what we want. This is not something we want to maintain. We do want to track, and we do want it to be, we do want the incentive to avoid it where we can. And it looks like we've done that. But the point is that we've built this in, we've now included in pollutants. Yeah, I can stop the screen share, or maybe I can keep the screen share up and open up the floor to questions. Any questions from anyone? Or Robin, actually, I've been doing all the talking. Robin, do you want to enter the fray here? Do you have a word to say about this?
Yeah, wait a minute.
Yes?
Can you, okay, people can hear me?
Yes, I can hear you.
Okay. Just remember that the first run he does, we're starting with totally arbitrary prices. And that's why it takes so long, that's why it takes 55 or 60 rounds. Now, but, and before, so you might be tempted to jump to the conclusion, oh man, that takes a lot of time. When will we ever have time to do that? But the important thing to remember is we'd never have to do that, because once the economy is run, you don't start with arbitrary prices. You start with the prices that you ended up with the previous year. And that's why it only takes something around 6, 7, 8, 9, 10, 11 rounds of proposals that councils would have to make, because you're always starting from last year, which is way better than just a total arbitrary set of prices. And even in the first year a participatory economy would run, you don't have arbitrary prices. You have the prices from the previous capitalist economy. So when you're thinking about, well, what are we discovering about practicality? The original runs, that take all those iterations are basically irrelevant, because that would never happen. The only thing that matters is what Mitchell calls the augmented reset run. And that's the whole point of, well, just how many times would councils have to be revising proposals and making new proposals? And I guess what we've discovered is that before we put in the pollutants, we were almost always at 6 or 7 times. And now it looks like it might creep up to maybe 11 times. And then the question is that something that could be done by councils in the month of December in order to be ready to start the next year? And I think it's still, I think we still are able to make, a case that the practicality that it seems to be quite practical. But Mitchell, yeah, we should, if anybody has questions, you should ask.
Yeah. Any questions from anyone?
Yes, I have a question.
Go ahead, Jason.
In the formal model, you have communities of affected parties who are the decision-making bodies or the people that come together to say how much pollution they're willing to tolerate. Mm-hmm. Did you decide instead, just for simplicity, to not do that for the simulation and just have the consumer councils to be the ones making demands for pollution?
Robin, you want to answer that, or do you want me to answer that?
No, we have the community effective parties. Now, because we only have one pollutant at this point, we made it a global pollutant. So the community of affected parties it's the coalition of all the consumer councils. So it's the national, and one of the things that Mitchell and I have talked about is that if we want to make this closer to what we're actually proposing, we need to introduce a pollutant that is not a global pollutant, where the community of affected parties wouldn't be everybody, but would be perhaps only people in a certain state or only people in a certain city. And we've talked about doing that. And Mitchell, you can chime in, but I mean, it is a little more work, and it's something probably worth doing. If we can get somebody to pay us to do it, that would be good. But yeah, in terms of thinking and talking about it, we have now included the community of affected parties of pollution victims. But because it's a global pollutant that affects everybody in the nation, that community of affected parties is effectively all of the consumer councils.
We can code up different, in fact, up to now, all the consumer councils, as well as all the worker councils, live in a single giant federation. We can code them up to make them into smaller federations that then interact with each other somehow. In fact, that model calls for that, but we've never coded that. And we need to think about how we would code that in order to implement this. And that would also include in different communities of affected parties as part of that coding. Robin and I have agreed to meet in about 2 weeks to start discussing the planning for figuring out how to do just that.
And by the way, Jason, the same thing applies to the public good. At this point, we only have one public good, and it is a public good consumed by absolutely everybody. But of course, in the real world, you have different levels of public goods, and we would have to do something similar in order to, I mean, I think what would be compelling, what people would like to see and what would make the whole demonstration more compelling is we really just need to add one extra level for each. Let's have one level of public goods that only affects people in a state, for instance, and one level of and one kind of pollutant that, and we're talking about how to do it. If I remember right, Mitchell said, unfortunately, that means that it does pose some extra problems on going back and coding things differently.
Yeah, but that all depends on how we code that and how we model the data, the councils, and how they organize with each other. I read this as a fixable problem. It's just that we'd have to think about how we want to do this.
Okay, right. Yeah, I've got it. Thanks.
Thank you, Jason. Other questions?
If no one else has a question, I have a couple.
Yeah, go ahead, Michael.
first, thanks for the presentation. It was really awesome to see this up and running finally after many years of talking about it.
Yeah.
It's pretty cool.
Thank you.
So 2 questions. The first one is, and I think Robin kind of talked about this a little bit, but I noticed that the initial round and the second round, the rounds increased, but the first round, it seemed like the rounds increased a lot compared to what it was, the results you were reporting in the book. But what I found interesting, maybe I'm not quite right, but it seemed to me like within a few rounds, the pollutants turned blue or green. Am I remembering that right?
Yeah, they do.
Like, okay. Well, I'm just curious because it seems to me like then the problem of the rounds going on seems to be related to the goods if the pollutants are blue or green. So, I mean, did you study kind of how the pollutants are affecting the good part of that? Because it seemed like the pollutants became green or blue pretty quickly. So I was just trying to wrap my head around why it was taking so long. When in the past, without the pollutants, I think you're getting like, was it like 12 or 13 in the first round or something like that?
Well,
but,
to be fair,
question.
I mean, what we're talking about is this is the result of a year 2 experiment. We brand new economy. We have a year 1 that was basically to figure out a calibration, which can take a lot longer. In the model, and it's not just this. I mean, like, this is much smaller than the results we'd produce. We got up in the value of 30,000 councils, worker councils, and consumer councils, each for an economy of 40 different experiments that we ran that were then published. So we're not even at the scale that we would need to be for publication in a peer-reviewed paper or in a book, for example. We need to scale this up even further, but also along the lines of what Robin had mentioned, we want to also handle, because we're now we want to try to map the model better. We need to be able to build out different communities of affected parties and also different arrangements of councils that be able to handle scales at the local, regional, national, and international levels. That right now, the software, we don't recognize that. It's just all one big soup of worker councils and one big soup of consumer councils.
So in other words, there's more work to be done.
There's more work to be done.
Yeah, Michael, we also noticed that the pollutants seem to be converging faster than the private goods, for instance, or the intermediate inputs. And that was different from before we had introduced the pollutants at all. I think it's just sort of an arbitrary consequence of what kinds of coefficients we picked for the pollutants in both the utility functions and the production functions. Mm-hmm. But I mean, it's just something that until we saw it, we noticed also that we were converging faster in the pollutants than some other places, and we're not quite sure what's making that happen. I'm not sure it means anything, but in any case.
Yeah, and I did have one other question. So when I was trying to code this, I never finished it. I couldn't quite get working. I kind of scrapped it, so I never kind of dove into why it wasn't working right. But one of the problems that I remember running into is that I got into this kind of oscillating behavior. I think we've talked about this before, but basically there'd be scenarios where they would say, hey, okay, we supply you with this right to pollute, and the price would adjust, and then people would make the adjustments, and the price would go back down after they make the adjustments, and then that people look at it again and say, oh, I guess I can pollute again, and they would bring the pollution back. It would just be like kind of this back and forth. And I was curious if you ran into that problem also in this work, and if you did, what did you do?
Yes.
No, we didn't. Go ahead, Robin.
No, I think that happens. You can think of it as a problem. It would be nice if everything always moved in the same direction and didn't go back in the wrong direction. But I think that's one of the things we've discovered, that you can't make that happen. And the way you see it happening in our demonstration is when boxes, sometimes a box got to blue or green, and then in the next iteration, it went back into a worse color. And that means it's doing exactly that thing that you found annoying and troubling. But I think that's just part of that's part of the nature of the beast. When you're adjusting interconnected, these are all interconnected. And when you adjust, sometimes one gets farther away while the others are getting closer. But the phenomena that you're talking about, that you ran into and you were concerned about, you're seeing the same thing when we have boxes that in one iteration, the color looks like, oh, we're pretty close. And then for that box in the next iteration, it's even farther away than it was last time. So that is happening in our iterations also. But my guess is that when economists look at this, they would assume we'd done something fishy if that never happened.
Right, yeah.
Thank you, Michael. Other questions? Okay. For what it is worth, the software is online. You can look here. I'll be sending this out as well. Pequod Plus is the name of the software. There are instructions for running this, and you can follow through if you're interested, or ask me. Unless there's anything further, we can continue on with the meeting, and I will stop the recording here. Thank you very much, and I hope you enjoyed it.